Alrighty, I think we're good. Just got to make sure that my typical window closing events are all closed, that I don't leave Discord or something open before I stream. Yeah, we're good. Hey Vixer, how's it going? I know that not a lot of people are here yet because I didn't schedule it until very late, but where's our examples? These are the examples. And where is resources Tracy? So we looked at Tracy's stuff on the last stream a couple days ago. And we were using the visibility tuning mesh example with the Tracy features. So we can run this and it will run a visibility mesh that is kind of a proof of concept. There's some stuff here that has to happen to make this like a full demo and a couple of edge cases that still need to be handled. But overall, it's doing the thing. It's doing a 360-degree sweep of all of the vertices for all of the meshes in the scene, except for the ones that we don't want to intersect with. And then it takes advantage of the fact that these meshes are counterclockwise face directions. So we get to say if we hit the vertex right at the bottom of this sphere, for example, then there's going to be a sphere, all right, a vertex to the right of it. That is the next vertex in the mesh list, which is great because that makes everything really easy for us. Now, we don't handle things like being in front of other things. So you can see some of these vertices do make it to like the end of the sphere, which overlaps with the next shape. But that's a thing that we can encode here. And then this is, yeah, so it needs a little bit of work, but all things considered, a decent start. We were trying to use Tracy. So we did some RenderDoc stuff last stream. We were trying to use Tracy last stream. Tracy has some, I don't want to call them issues. Tracy doesn't supply a Mac OS build, and Homebrew's Tracy build is out of date. So if I run this with the Tracy application open and I click connect, this all works. It's really cool. You can see a bunch of stuff happening. Then we stop and we have everything working. And the download for this, let's see if I can find the link off the top of my head. If I have my /Tracy builds. So Lon, who was in stream the other day, was looking at how much effort it took to get a build of Tracy and put together this organization and repo that basically just builds and does a GitHub release for the Tracy binaries for all the platforms, which is great because now if you want to use Tracy, all you have to do is go here and then download it for Mac or whatever. And then you have Tracy locally. And thus it has become extremely easy to use because you download it, you run the profiler, you run your application, and now you have a trace, which is so significantly better than anything else that we were trying to do the other day. Some interesting things here. You can click on like statistics. There's a function here called calculate visibility. Can I paste the link? I can paste the link. Give me a sec. Switch over to my other computer and get the link. Here's the link. 12.2, 0.12.2 is the version that latest Bevy is using. So that's the one you want. So we have a function or a system called calculate visibility. So I'm going to look at statistics and I'm going to look for calculate visibility. And here we go. system, visibility 2D mesh, name of the crate, : calculate visibility. Here's all the statistics for that system, which is really cool. Here's our mean time, median time. So median is about 80 microseconds. It looks like one or two of them might have taken a really long time. Not really sure why that is, but you know, the occasional spike up to 200 microseconds instead of 90 is not really that worrisome to me. The vast majority of it is where we want it to be. Or rather, we didn't do any performance work on this, so it's not like where we would want it to be, but like it is reasonable, right? A system running in 80 microseconds to touch every vertex in the scene is fine. It's not like we're talking about milliseconds or something. Yeah, bunch of information and stuff. Flame graph for this one, not interesting, like really at all. There's really like nothing going on here. So unfortunately, yeah. Hey, Nas, how's it going? We didn't collect memory. Memory is a different flag for Bevy. I forget what the flag is exactly, but it's in the instructions now. Lond made a PR to the actual Bevy repo, which should help people find this repo and also figure out how to do this at all profiling. So this now has some extra Tracy information, including the trace memory. So if we stop this, profiler with the trace memory flag. Hey, Luis, how's it going? How's your, I guess, morning, afternoon, night? I don't know what time zone people are in. Just talking about Tracy a bit at the beginning of the stream. But this is these distributions are very, very cool because they are not like complete new builds or anything. The Tracy repo already does builds for like Mac OS and stuff, and it already has build instructions for all the platforms. So the extra repo really isn't like maintaining a whole suite of build scripts or something, which makes it much easier to like maintain that little bit over time as things update. And also a lot easier to like trust that repo and that it didn't deviate from what Tracy upstream would be. What's the difference between the external repo and the main Tracy downloads? The main Tracy downloads do not offer a Mac OS download. If you want to run off the master branch, Tracy does have downloads that are archived. So if you go to Tracy, right, this is the actual Tracy repo. If you go to, say, here, this is CI, GitHub Actions for all the stuff. You go to, say, Mac OS or something, you get details, and you go to summary. This will have a couple of artifacts. As far as I can tell, they build Mac OS, they build Windows. These artifacts get uploaded because of the GitHub action. But that's only if you want something that is like main and latest, which is not compatible currently. The protocol that the profiler and the capturer use and stuff like that needs to be exact. So like if you're using 0.12.2, you need to use 0.12.2 everywhere, which is unfortunate because if you go to the 0.12.2 GitHub release on the repo, they only have Windows. They have source code in Windows. So you can either build it yourself for Mac or you could download the Windows build. Which is unfortunate because they do have the binaries in those GitHub Action scripts. So really all the external repo is doing is taking the scripts that already build those binaries and just turning those binaries into a GitHub release. It's not like doing a whole bunch of work in terms of new build scripts and new logic and anything. It's just taking the binaries that already would have been there and putting them somewhere you can access them. I should probably not be running multiple Bevy applications at the same time. That would make sense. So we'll run this again. We'll hit connect. Not really doing anything in the repo, so that's fine. But we can now take a look at memory, and this actually just shows us total allocations, active allocations, memory usage. Kind of cool that our application is running. It is not really using any memory, 43 megabytes. The active allocations look like they're steady within 100, which is kind of cool. So there's obviously some getting dropped and some getting created, enough to like really make this number go up, but it's not really changing the total allocations. You can get really deep in here. Here's our memory map. If you like looking at active memory, et cetera, et cetera. So it's very cool that this exists. It's very cool that this is accessible to people on Mac and stuff now. And please, did Tracy just crash? No, just had a hard time. So yeah, Tracy is available now for people, which is very, very, very cool. So everybody thank Lon next time you see them in chat or around the Bevy Discord or whatnot, because that is super valuable work that they've done there. The other thing, I got kind of distracted this morning and I ran this demo. So I just have it as like __ test right now, which doesn't render anything. So we're not going to look at that. But the logs here are basically, there's an observer that's firing hit events at specific entities. We have a global observer. Just joined, trying to catch up. Is Tracy better than Perfetto? Tracy will show you real-time stuff locally. So you don't have to like just save a capture. Since you weren't here, I'll go back and run it again. Since I still have everything up here. So here's Tracy, right? We run, our application is running, we hit connect, and this is all the data filling in real time. So if you were going to try to capture something that was very, very, very like more accurate, you might not want to run the Tracy CLI, or not the CLI, sorry. You might not want to run the Tracy graphical UI. You can also do this from the CLI, because obviously if something is rendering on the screen, then it is a competing graphical application. If you want your game to be the only thing running so that you can profile it, you probably want to do it from the CLI, which you can do. But yeah, I mean, you can do this, you can pause, you can look for stuff. We talked about finding, statistics for specific systems. So I can look for calculate, and here's calculate. And it's got a bunch of stats and standard deviations and stuff. So very, very cool. So show me all the slowest stuff function. Open Tracy. So here's a bunch of stuff. I guess I'll stop this. You do have a bunch of like sorting tools here. I guess it depends a little bit on what you mean by slowest stuff. You do get a flame graph, although the flame graph for my particular application is not actually interesting. As you can see, it's kind of just like a lot of prepare windows because there's not really a lot else going on. So it's a little bit hard to like show, how do I frame this? It's a little bit hard to show like, hey, this is like an actual performance problem. And we saw it in the graph software and stuff because we don't have a performance problem. So we're not going to see a performance problem for something that we don't have. But there's a bunch of statistics and stuff. Cool. So what I was about to get into, cargo run, is this application. This application is, I hesitate to call it anything more than a demo. I don't think I'm going to push it to the Bevy examples repo because I don't know that it's really something that people should generally be doing. I did push it to my own blog. So if you want to read a little bit about what's going on here, the blog post is up on my personal site. But the TLDR here is most people think that you can write this function. Where is it? That's commented stuff. Most people think that you can write this observer and that it'll work. And it'll work in a way that when a death event is fired, it will only filter for entities that have the practice enemy and component on it. And that's just not the way it works by default. But I've written the code to make this do the thing that people mostly want it to do here. It is kind of hectic, but you can see here that there's one, the one we just saw is this one. This is the handler for practice enemies or like a target dummy or something. This is the handler for the player that is an observable. And then these observers are the 3 global triggers. So it triggers for 3 entities. 2 of them have custom observers with filters. 1 of them does not. The plugin that is triggering these is like a health plugin. So like a generalized, like things have health. When they get hit, you remove some health. And these are the components for which we are allowed to filter. So here's the specific observer that filters for player. Here's the global observer that doesn't filter at all. So it just, for any entity that this fires on, it'll trigger. Here's our entire application setup, which is significantly smaller than the rest of the code. So we've got a player with some health points, we've got an enemy with some health points, and we've got a practice enemy with some health points. And we trigger the hit event for each of those entities. I don't know how interesting the mechanics of this are to people, but the system that reacts to those hit events is kind of contrived. But basically, anytime that event comes in for some entity, it removes 10 health from that entity. If there's more health, then it just sets the new health and we continue. If it hits 0, then we queue a death command. The death command is responsible for getting the list of components that we can filter for and checking to see which of those are actually on the entity, and then calling trigger with only the components that are actually on the entity. So trigger with is a variation of like observer trigger, right? Trigger an event, you can trigger a global event, you can trigger an entity event. Trigger with allows you to pass in this additional trigger. For global triggers, this would be called global trigger. For entity events, I think this is called entity trigger. For entity component events, so life cycle events like on add, on remove, on insert, this is called entity components trigger. And this field of this trigger controls which components are kind of like valid, right? So any components you put in here are considered valid. So if you have a death observer event handler, and it is filtering for a specific set of component IDs like player or enemy or practice enemy or whatever, if that component ID is in this list, then it fires that observer. So yeah, I don't know. The details are on my blog. The implementation here is pretty straightforward if you have some like intermediate level Rust knowledge. The health plugin accepts a generic that is bounded by bundle. So you have to implement bundle for whatever types you're passing in here, which is pretty typical. That's how people are used to using components. We make sure that that bundle is registered with the world, and then we get the individual component IDs for all of the components in that bundle and store them in a vec in a resource. Once we have this resource vec, the other thing is you have to specify the trigger on the entity event attribute macro for the event. But once we have those filters, all we have to do is grab the filters, check which ones are actually there, and then trigger it for the ones that are actually there. So overall, not super complicated. But if you don't know what the APIs are, if you've never seen traits or something, it can be pretty complicated. Tracy works on Linux. You had to chmod x the binaries. You're stoked. Who do you thank? You thank Laund. LAUNDMO is their GitHub username. If you are on that repo, it's their username on the repo. They are in the Bevy Discord. If you would like to thank them, there's a post in Showcase for the Tracy stuff. That would be a good location for you to go and thank them. Oh, that didn't send me to the profile. Come on, send me to the profile. This person, LAUND, is who you thank. So very excited about this. This is like super. Now I can actually tell people to go use Tracy. Instead of being like, well, if you want to use it, it might be built for your platform, or you might have to go build it yourself. You know CMake, right? Which obviously doesn't work for people. So I thought this was a really cool demo. I don't know if I'm going to use this pattern for anything. I don't know. So implementing a custom trigger is interesting. I haven't looked into it really all that much because I haven't had a reason. But trigger is a trait, and trigger has this unsafe function called trigger where you can do things here and you get access to, you know, the event and the world and stuff. So I think actually we could have not just an entity components trigger, but we could have a, let's look at the implementation over here. We could have not just an entity components trigger, but we could have a entity component filter trigger or something like that. Or like active entity components trigger. Now, if we did have that, you would have to pass in this data at some point somehow, right? Because otherwise, like, I think the reason this doesn't exist currently is because how do you tell which components to fire it for? And an entity can have something like 20 components. So if you fire this at an entity and it fires for 20 components, that is kind of like a large increase in the number of like observer calls that are not being used at all, but are being fired. So you have to have this like safe list here for it to be reasonable. And I don't actually know how you would pass in that safe list in many cases. Because passing in the safe list every time you call trigger is kind of annoying, right? That's kind of like the thing we're trying to avoid by writing our code over here, right? Because like commands queue this command doesn't need to do that, right? We just need to queue the command for the entity. Just trigger with our event, right? So if we can take this logic and stick it inside of the trigger, maybe we can make a command extension. Maybe I can release this as a crate with a command extension where the command extension will actually give you like the ability to filter or the ability to, you know, create many of these. Because like it doesn't really work in a generic way. It doesn't work for everything. It works for if you have a list of things that you want this to be able to filter for, you have to provide that list and then you have to trigger it. And I think that when it comes down to it, that's why this isn't currently upstreamed. Cool. Guess I can get rid of this right now. Oh, I started working on, do I have Blender open? I started working on, let's remove this component, reinsert this component. This is Skeen, right? This is an unfinished Skeen feature. So it's local and nobody else has access to it. But I can add a couple of different strings here to this vec, right? If I want to add something up here, I can go here and goes like CC. So vec of strings now supported in Skeen as of whenever I merge this and publish it. This was really annoying, actually, to get working. This was Python stuff, so we're not really going to get into it because Python stuff isn't really what we do on stream. Or at least it isn't what I explain on stream. But this whole thing is very, very annoying to build out. We have this whole function where we build up types dynamically for all of the components. And Blender doesn't have like just here's this array, we'll maintain the index for you. You have to put the index somewhere, which means that you have to, for a vec of strings, you have to have a root type that holds the active index and the vec. You have to have the vec, and then you have to have the items in the vec as a separate type. So you end up with 3 different types chained together to be able to render an array of items, which is a choice. And then once you get down to it, you can't actually send data between operators. You have to send paths. So where's the thing that I was doing? It's probably in the panel. Here we go. This is disgusting. This is like the kind of code where it's like, this is just how we have to do it. But this is disgusting. What this is actually is when we have our template list here, right? And you click that plus button, what happens is that we take the object that we're dealing with, we turn that object into a Python evaluable string that represents the path to the object. That ends up being like bpy data objects cube, scheme2, array index 0, the path for the actual module as the hash map name, and then like a key inside of it. Like it's a whole thing. Now the way they expect you to use that is eval. I refuse to put arbitrary Python evaluation into this extension. So we are doing a little bit of parsing here. But anyway, it's not as easy as just like sticking a vec into, or sticking an array or list or whatever into Blender. It's a huge pain. You need to get back to learning Rust. Where are you in your Rust journey? We were working on some Rust educational material on Wednesday. I was actually just looking at, this is a workshop I came up with like a long time ago for Rust Adventure. This is the entire workshop. This is obviously for beginners, right? This is for somebody who's like never written a Rust application before, like ever. They don't know what an iterator is. Yeah, eval, right? Like I saw that. I was like, okay, so I need to repr this, which hopefully gives me the string. And then I can hopefully eval, which executes arbitrary Python code. I'm going to put some extra elbow grease into this and make sure that we don't have to use eval. Because that just sets off so many warning bells in my head. It does mean that we kind of have to write that like disgusting code that I just showed, but it's better than having eval. You're just getting started. Main Conway's Game of Life with Bevy as a Hello World type thing. After that, started doing Advent of Code problems in Rust. Took a long hiatus though. Nice. So you're looking for your next project at some point here. I think one of the things that, so we were working on Rust Adventure workshop kind of stuff, right? On Wednesday. Here was our outline for that. This is meant to be like Rust in under half an hour kind of vibe for people who know some other programming language. So if you don't know how to program at all, this video is going to be a little bit too fast-paced for you. If you know some other programming language, then it'll be far more reasonable. Wow, that didn't clean my glasses at all. That's what I get for not using like a a thing that isn't my shirt. Later, Nani. You came from Python mainly before Rust? Cool. Yeah. So you know what I mean when I say that I'm reppering this and then have to eval it. That is scary stuff. Yeah, so we've got some videos that would be like prequel videos, like why Rust and what is Rust good for, and like there's a bunch of other videos that maybe aren't. Maybe they're before this, maybe they're not, but they're just like separate videos. You're waiting for Rust eval. Oh man. I mean, not that it wouldn't be interesting, but the terrifying nature of just being able to execute arbitrary Rust code. Yeah, so we have that prelude bit of it. We have the actual stuff here. This will all get scripted out and stuff over the weekend. And then we have a couple of other videos afterwards. These are not the videos that are going to come after it in terms of the language. So there's going to be I'm just going to add more headings to this thing that we are typing out. You wrote an interpreter for a custom language. Biggest mistake and pile of bugs was eval. Yeah, that makes sense. Your next project, or at least your dream project, would be some kind of simulation that could allow for emergence and complex behaviors to arrive. Cool. I guess that's why you were doing game of life stuff, yeah? I forget. Oh, man, I'm blanking on what those are called. Cellular automata. So you're going to try to do some kind of cellular automata application? Somebody did that for Bevy Jam, actually, if you're interested in that. I think it was the last one. Maybe it was either 5 or 6. Let's see. Results. I think it scored pretty highly. So we're just going to look at the abiogenesis. Abiogenesis is I think the thing that I was thinking of. Turn my laptop sound off. There is audio. So this is like just a bunch of sliders and seeing how things react. But what you were saying just kind of like reminded me of it. Define some rules, see how things go. I think you can actually zoom out here. If I remember correctly, they did an implementation that was on the CPU, and then they did a separate implementation that was on the GPU, and they were able to do significantly more on screen in the GPU implementation. That's pretty close to how you visit it in your mind at times. Nice. Yeah, it was very cool. It scored pretty highly. People enjoyed it. So definitely an interesting project. From a Rust language perspective, you find you come with the best ideas and you're just sort of zoning out and laying down, trying to distance yourself from your thoughts. Yes. Trying to like take a break, take a walk, let your brain cook on something. Absolutely. Agreed. The larger vision for Rust Adventure is something that looks kind of like this. It's kind of like, we'll say the Why Rust video. Then the video we worked on Monday, which is, I'm just calling them videos right now. It's just a loose connotation. It doesn't necessarily mean they are like an individual video. It just means like a group of content. This one is like Rust in less than 30 minutes. I don't have a title for what this is called, so I'm just going to call it that. And then it comes into the thing that I started doing Rust Adventure with was a plan that would be like, there would be a set of pipelines here, right? And you could go through the Bevy pipeline or the CLI pipeline or the WASM pipeline or the web backend pipeline. And you could start at any of them and end kind of anywhere in any of them, or do like flip between any of them or whatever. People don't like this. People don't like these separated pipelines of stuff. So I think the next generation of Rust Adventure stuff is going to be these 2 videos and then a linear Rust language workshop. Right? So this is like, I don't know, we'll call this like Rust 2024, right? Because that's the current edition. And this is like Rust book-ish. It's not really Rust book. It's not really a bunch of other things. There are some examples of other, what's that Rust Google course called? Comprehensive Rust. There's a lot of things that look exactly like this that are like, here's hello world, here's types and values, here's variables, here's how you do arithmetic and whatever. And these are okay. But if you already know a programming language, then do you really need to be told what a plus sign looks like? Right? Like, if you already know a language, you kind of just need to know, oh, when you write a Rust function, it uses fn instead of func or instead of function, but it's still a function. You used to come up with a lot of ideas. Now you sort of let the good ideas ferment up, and instead of just coming up with a bunch of disconnected, grandiose ideas, antipsychotics have slowed down a bit. Yeah, heard that a lot. I've heard that from close friends who have had that experience, is the way they'll put it. The simple HTTP server from the official Rust book was cool. Good times. Yeah, the Rust book. So one of the issues with picking projects, and this is like the final project of the book, right? This is like, you've made it. You're going to do a web server. When am I going to build a web server? Like, it's cool and everything, but when am I going to build a web server? If I'm going to do something like offer a web server, like an HTTP endpoint or something, like I'm going to reach for something like Axum because it has all the features that I need. Or I'm going to reach for something else that does RPC, right? Or like, depends what you do for work. Do you write do you just write like TCP listeners at work? I guess maybe database stuff. Oh, implement an embedded mini web server for small robots. Yeah, but like even then, like that gets embedded into a crate at some point, right? Like somebody builds an embedded microcontroller web server. And like, yes, somebody has to build it first, but everybody isn't going to build an embedded mini web server. You know? You need to learn how to go with the flow of the borrow checker instead of fighting it until it just works from tweaking around. Ooh, yeah. Lifetime's ownership. I think we mentioned ownership in the initial video, but like, I would love to go on deeper dives of, like unique Rust concepts rather than reference material, right? Like there's something, how do I frame this? I'll use the Rust book as an example because the Rust book is absolutely like, it is a good resource. I have no like qualms about it as like a general resource, but it verges on like school style resource might be the way that I frame it. Right? Because you have to hit installation. You have to say, okay, here's how we run a program, right? Cool. Once you do that, why did that sidebar disappear? Once you do that, do you really want to cover a chapter on functions and a chapter on variables and a chapter on control flow and a chapter on whatever? Like there are unique control flow things about Rust, right? Like you have to mention that Rust is an expression-based language. There has to be a video on that somewhere. You have to mention at some point that variables are defined with let and let mute, right? But it's very referencey. It's very like isolated in that sense. Like here's some data types, right? And I want to be clear. I don't mean to rip on the Rust book or anything, but if you come to this page and it says data types and it's like, okay, this is parsing a number. I might need to parse a number. Here's some error messages. Here's the scalar types. Here's the integer types. Here's integer overflow. Here's how you do numeric operations. Here's the Boolean type. This is a reference material, right? It is a material that you can go check anytime you want to actually figure out how to do something when you need to do it. If you can't remember how to add two numbers together in Rust, you can go to the data type section of the Rust book and it will tell you how to add two numbers together in Rust, right? There's plenty of reference material. So I don't really want to focus on being like exhaustive in that sense. I want to focus on things that are practically useful for somebody who's trying to get into the language sooner rather than later. So like when we talk about things in the intro video, like the 30-minute video, right? We talked about things like it's expression-based and ownership, and these like probably deserve their own videos or their own sections. So like ownership, lifetimes, maybe we specify something a little bit more about like generics and traits. Right? Like but like we need to come up with an overriding question as to like, what are we answering with this chapter? We can't just be like, oh, we're going to talk about ownership, right? Why ownership is the big question, right? Like why lifetimes? Like what do lifetimes do for you? Not what is the syntax of a lifetime? And like, obviously we will cover syntax because you can't talk about the lifetimes without showing some code. Well, you can, but it's less useful. And like, why generics? Right? Why traits? What are they useful for? What are you going to actually use these things for? So coming up with good examples that are like the core of each of these sections, I think is going to be the model, right? So like ownership, what is the example for ownership, right? Is the example for ownership just sharing some arbitrary data? I feel like there's a lot of different ways we could go there. Generics and traits. Like, why would you want to trait? When would you want to trait? I think like when you talk about generics, you end up having to talk about like vec_t and stuff too, right? Like, here's a vec. Why does it matter? The basic C++ iterator mess up example. What is the basic C++ iterator mess up example? I'm just going to assume that it comes up on the first learning resource. You iterate over a vec. Can you not iterate over a vec? In C? So you have to do vector string iterator it equals cars begin rather than doing the... So you have to create an iterator, set begin and end, and increment. So I assume people just forget to do this and they do it over the vec itself, is what you're saying? And push delete while holding the iterator? Oh, like you modify the iterator while you're working with it. And then your iterator is kind of like in a semi-weird invalid state. Yeah. Yeah, I don't think multi-threading. I think that there's like an intermediate, advanced Rust kind of stuff. I don't know which one of these is going to fit everything. Um, maybe like using async goes here, right? And like writing an async executor goes here. And maybe writing an async executor is actually its own series of videos rather than just being like one video. This is the most basic example of the borrow checker fixes. Gotcha. It's wacky. More modern C++ might not be that way. Last time you dealt with it, you realize most C++ docs can be decades old. Yeah, I mean, it's been around a long time. It's what, 40 years? 80s? When did 60s, right? So almost 60? '78. I guess 72 technically. So 53. It's a lot. It's a long time ago. For a programming language, 50 years is wild. Where was I? So yeah, like this might not even be quote unquote advanced Rust, but like advanced Rust might end up being like larger topics, you know? Like I don't know if WASM Basics is intermediate or advanced. I probably is intermediate, but it starts to get into like no standard stuff. And I feel like no standard like embedded no standard embedded has to be its own. Like it's its own full category, right? Like this is, you know, ESP32, whatever. This is like Pico W, Blink and LED, etc. Right? Like there are like that breaks down into a whole area. Same thing with like Bevy and stuff. I think that no standard is probably relevant to the language. I think that embedded, maybe not. Maybe embedded is its own thing. Like the distinction here is if somebody wants to come and learn a specific pipeline or whatever, I've found that people looking for language stuff want a linear path. People looking for Rust educational material really want a linear path. They want to be told what the next workshop is. They want to be told what the next course is. Do this lesson, then do that lesson. So this idea of pipelines that I really started Rust Adventure with really fell flat. I think that at the end of the day, this is what happens. I don't know that these are the right names for it, but like, you know, whatever this is, alternative naming scheme is like bevy.rustadventure.dev subdomains. But this is moist. I don't even know what that means. um, The thing here is that, like, I think people landing on Rust Adventure really want language stuff because it says it's Rust language stuff. It's extra moist after this. I don't have any idea what you're going for here. Like if you're gonna do web backend stuff, right? Like web backend stuff is gonna be like Axum, it's gonna be like JWTs, it's gonna be like regular handlers, JSON, you know, form handling in some respect. Probably JSON and form handling maybe are different things in terms of like where they're located in the content. Because like form handling comes from HTML, JSON comes from, you know, typically either front-end APIs or people who are like sending curl requests or from other microservices or whatever, right? And then there's a whole bunch of stuff here around like protobufs, etc. There's a whole set of like SQL stuff. I think SQL stuff, I don't know. It's tough to say SQL stuff is specifically backend. But making a separate site for SQL stuff also feels weird. Leptos, right. Right. Like Leptos is another one of these where you kind of want to build up some WASM stuff. WASM is interesting in so much as it gives you some exposure to like FFI and gives you some exposure to like compiling Rust to a different target. But like once you start hitting advanced Rust, like not everybody's going to write an async executor. Not everybody cares about concurrency. Not everybody wants to write a WASM thing. Not everybody's going to do an embedded thing, right? So it's like it splits quite a bit once you get to advanced stuff. So like the question is like, is WASM actually part of the Rust language stuff, or is it completely separate? And if it's completely separate, then it's like not necessarily Leptos Adventure, but like Rust for websites, you know? This is such a bad name that I would have to find something else, but like... and the point here being that it's like, it's all still the same thing. It's all Rust Adventure, but people really care about landing on a place they can then take a linear journey on. So landing on the Rust Adventure site and taking a linear journey through the language content, or landing on Bevy Adventure and taking a linear journey through Bevy content, or landing on the command line stuff and taking a linear journey. Like you can always access all three of those things whenever you want to. But it's very clear what the goal is on each one of those like subsites. So we're starting with making Rust Adventure have significantly better language stuff. So all of this stuff kind of is for a little bit later. We have to finish this stuff first. Not all of this stuff, not the advanced stuff necessarily. But like, having a task for each of these would be interesting. I waffle between picking the wrong example will lose people and picking no example and just doing reference content or like dry technical education, like university style research level content also loses people. So I think we have to pick examples, and really the work of these particular sub areas for like ownership is picking a bunch of examples that show what ownership is and why you should care. And I think that that fits very well with the stuff that I'm doing with the Bevy examples right now. Right. There's a folder in here called concepts in the Bevy examples repo on Rust Adventure. And it includes things like spawning, relationships, hooks and observers. There's a folder on maps right now. And it's kind of like, okay, if you want to learn how to create stuff, here's 7 examples for how to spawn stuff and different ways you can spawn stuff, etc. So like maybe that's a little bit dry because these are contrived examples, right? Like this is an example for spawning an inventory. It's 150 lines. Do you care specifically about an inventory? Probably not, but this is a custom relationship example, right? So I think it's going to be the same kind of thing. And we're going to want to build up a set of, I want to build up a repo of concepts with folders that are the high level things that we really care about teaching, like ownership, like lifetimes, like generics and traits, and then filling out those examples to figure out what is supposed to be in these things. So right. Because it's easy to just name language features. Right? Like I could easily just be like, oh yeah, obviously we should have a section on iterators. But like, why do we have a section on iterators? What is the purpose of talking about iterators? What do iterators allow you to do? How are they used in Rust? And the why really matters, right? Because I could just say iterator is a trait. It has a next function. There's a whole bunch of other functions that you get when you implement a next function. You can call this to iterate over vex. Is that really interesting? Like an iterator iterates over vex is something you can find out from like a 30-second Google search. How do I iterate over a vec? Or how do I, enumerate a vec or whatever? And like the first result is going to be like use an iterator or like write a for loop. So like, is that really interesting? That's something you can get from anywhere. Upholding invariance, the iterator protocol. Keep that as a note. I probably won't use the word protocol, but like why are iterators the way they are and how does that affect how you use them? And why is it useful that you can do like .iter, .map, .whatever, right? Right, like what implications does this have versus writing an explicit for loop? It's literally called the iterator protocol. I don't think I've ever seen iterator protocol in reference to Rust stuff. It's somewhere in the reference. Oh, protocols as in like the traits protocol, you mean? Not like a standalone concept, but just like what the trait is and what it means to that's kind of what I was referring to earlier, right? Like the iterator trait requires that you implement next and then provides you all of these other functions. Yeah, absolutely. Right? Like talking about the idea of a required method that can then give you more functionality. Yeah, returning none, definitely, absolutely. We have to talk about associated types if we're going to talk about iterator as well, right? I missed a chat message. I'm going to scroll back. It's important to know the difference between iter and intuiter, and that 4x and vec is syntactic sugar for intuiter. You're asking, is it important? I do think it's important. I think it's important in the sense that like .iter mostly gives you references and .intuiter really takes ownership. Right? That's kind of like an ownership consideration. I don't think that they are necessarily, strictly speaking, required to do things like that, right? These are not, hard hard type level requirements. Like intuiter can kind of do whatever it wants. But intuiter will usually give you owned types. Iter will usually give you references. I think like stuff like that starts to give order to the content, right? Because like iterators have to come after ownership if we're going to talk about iter versus intuiter and the difference in ownership. You guess you were more asking if it was something you would put in an intro to Rust course. We talked about iterators up here, didn't we? I think we may or may not mention it in the 30-minute video, right? We don't currently have it in the 30-minute video. I think we might talk, like the 30-minute video is going to get really short really quick, right? Like we're going to have like a couple minutes to talk about iterators, and talking about iterators by showing here's an iterator like extract diff, or here's an iterator like whatever, is going to be far more useful than talking about iter versus intuiter. But once you get past that and you start going into like, because these are more deep dives, right? I'm referring to them as high level concepts, but if we're going to have like a video on iterators and examples about iterators, we do have to talk about iter versus intuiter. Where will these videos be published? rustadventure.dev. So probably what I'm going to do is the first two videos are just going to go on the site. Like this little thing right here in the right-hand side, that's going to be why Rust. And then it's going to point you directly to, I'm going to change this whole homepage. I don't like the homepage. Well, there are things I like about the homepage, but the next thing is going to be the 30-minute video is going to sit like right here. It's going to be like, if you're not sure and you landed here from SEO, here's why Rust and what Rust is good for right here. And then the first video here is going to be, here's a 30-minute video to figure out if you even want to use Rust. Here's what Rust is like. Here's what an iterator looks like. Here's et cetera, et cetera. And then from there down is going to be like paid course content. So it'll be like Rust beginner stuff, intermediate stuff, advanced stuff, et cetera. So yeah, it will be in the intro stuff into iter versus iter. Iter's returning none. Like iter's returning none is like part of what iterator is, right? How do you know when an iterator ends? And the answer is it returns none. I think iterators have a lot of really interesting examples that you can use. You love Rust, but you're so conflicted on saying that a team project should be in Rust because the learning curve is so freaking high. Well, I'm hoping to do my part to soften that learning curve a little bit. I do think that Rust is not any more difficult than any other language. Most of the trouble that I see people have with Rust is preconceived notions from another language. Look at the learning curve of C++. Yeah, I've never finished. That's exactly what I was going to refer to. Yeah, I think that when it comes to learning a language, if you already know a language, your second language is actually harder. See ya, Galt. Because you end up taking a lot of like, oh, I've learned a programming language. This is how programming languages work. And then you see your second language and it's not how programming languages work. Programming languages are actually really different from each other in a lot of different ways. But if you start with Rust then it's no different difficulty-wise than any other language, I think. Things like joking about, the learning curve of C++ aside. I've seen people learn Haskell with no problem. And Haskell is like notoriously difficult for people who know other programming languages. But if your first language is a functional language, then it becomes like not really any more difficult than any other language. You've transitioned teams from Ruby to Go, and you're trying to consider to get teams off TypeScript, but you want to write Rust in production so much, you don't want it to bite you. Yeah, I hear you on that. Are you doing TypeScript for backend stuff or full stack TypeScript, like UI stuff too? Actually, your problems with Rust is boilerplate and lifecycles color when you need to add it for exist structs. Yeah, I mean, beginners in general, my advice is don't use lifetimes in structs until you really understand lifetimes, right? Because if you use lifetimes in structs, what you're saying is that somebody else owns this data and I'm passing this struct around, and that other data is going to live as long as I need it to use this struct. So like writing zero copy parsers from scratch is not a basic level, like introductory level Rust problem, right? I think that's at least intermediate advanced kind of stuff. There are libraries that I really like. I think Nom is the one that I use every year. I'm sure people are tired. Well, I don't know if people are tired of me talking about it anymore. I haven't mentioned it in a while. But Nom is one of the libraries that I really like. Winnow is a fork of Nom. Right. Winnow is basically Nom, but with somebody else's opinions covered on it. Writing zero copy parsers with Nom is reasonably easy, actually. Chomsky and Ariadne, yeah. Ariadne's error messages inspired me, if I remember correctly. I think there's an Ariadne, yeah, for pushing how pretty the diagnostics could be. This is the same kind of output you get with Miat, which is more of a generic anyhow error handling library. I think there's a lot of really cool parsing libraries. I would love to do a series of videos on a bunch of different parsers. Last job was TypeScript for backend and frontend. If you've pitched Rust or Go for backend stuff, because once you start getting serious traffic, TypeScript on the backend is goofy. Yeah, I mean, I will say that I really appreciate how stable the services that I've written in Rust are. I can write them, I can ship them, and I never need to look at them ever again. Like I just don't. They just sit there. They're rock solid. They don't grow in memory. I don't need to re-kick them every day. Like they just sit there and they do their work, and I never need to worry about them. You mean you need to change a huge part of code to add it? You understand life cycles. Yeah, I mean, if you're sharing something versus owning something, you can make a lot of different choices, right? Also, when you need to pass something into a closure, you need to clone some struct manually. And if closure has many elements, requires many clones, and no option to define auto copy struct. Yes. That is actually something that they are working on the language level. I forget what exactly it's called. Because it's a little bit too early for me to talk about in a video or whatnot. But they are working on that on the language level, trying to make clones into closures a little bit more ergonomic and not require you to write them like that. So hopefully that will make it into the language at some point. I forget what exactly we called that, or what that's being referred to as. I don't even know if I'm going to be able to find it. I don't think there's an RFC up for it. I think it was just a Nico blog post. Maybe it wasn't a Nico blog post. Maybe it was somebody else's. Handles were one thing. Is this what we're calling them now? Ergonomic ref counting. There's been a lot of on handles lately. Oh, that didn't even hit next. Oh, that was everything. That was a terrible. I don't think handles were exactly what I was thinking of. I think I was thinking of something else. I think this was it. Claims. The new syntax actually exists. Do you remember the name of the syntax? Well, use is not it's not the same thing, right? Um, I think it is handles. I think it changed maybe from claims to handles. I really want a link to the RFC or something. Here we go. Simplify lightweight clones, including into closures and async blocks. Only from 2024, so it's only been a year. Ergonomic ref counting, so it is part of that handles work. So hopefully this will come in. I think this is the use you were talking about, right? .use. So I do think landing something like this would help a lot of people. I don't think that this is the biggest problem with Rust for people learning it. I don't think that syntax and boilerplate are the biggest problems for people learning Rust. But handles and cloning into closures and stuff, definitely like a pain point for production users. Something that people definitely want to be better. Absolutely. And it is actually being worked on, which is great, right? Because we could be like, oh, it's a problem and nobody's working on it, which would be even worse. But like that's kind of a good point too. Like closures. Like capturing, cloning the capture, etc. Oh, no stress at all. Yeah, I know that people watch at a delay. If you say something later, some people come in and they watch at 2x speed and then they catch up. So don't worry about being a little delayed. So I would like to formulate this in a way that isn't just like reference of syntax. I think talking about closures, you have to talk about function, function once, and function mute. It's kind of hard to get away from talking about that and what those mean and what they're for. But I don't want to open that video or whatever with like, here is FN. Here's the definition of FN. Who learning? Maybe not. You just tried to develop with Diaxis and tired of writing clones. Yeah. Especially for UI stuff. Cloning is so prevalent in UI stuff. Because like everything isn't async in the sense that we call things async in Rust. Like it's not async await, but it is async in the sense that like basically everything is a closure that gets called at some point later. Which means that you end up with all of these clones all over the place trying to make this happen. And that, yeah, I totally understand why you would be tired of that. It's a pathological case for needing to clone into closures. The one thing that is nice about this is because it's not like any kind of official resource, we get to use crates. So like using async can be like futures Tokyo, right? Like we get to go say, here's Tokyo. Here's how to write async with a Tokyo runtime, rather than here's how to build an executor from scratch. You know, like talking about like what pin is advanced stuff, especially now that we have runtimes and async await syntax. Like pin is relevant, but it's not the first thing that you run into if you're trying to use async. So we had error handling is another one. Might deserve its own whole section, right? Right, options, results, like option and result being somewhat the same, right? You can take an option and turn it into a result pretty trivially. You can take a result and turn it into an option pretty trivially. You're either adding error information or removing error information. For error handling, because we are not like an official resource, we can talk about this error. And we can talk about one of these error handling libraries. I haven't decided which one we're going to talk about yet. It's either going to be anyhow, err, or miet. And anyhow probably is the safe choice. And is a good enough baseline. But in my production software, I kind of prefer miet. So it's hard for me to be like, in prod, I use this, but you should use this. It's a good thing that people use anyhow in production because like it's a common pattern. But err is another choice, like another possible choice. I think it's a valid choice compared to anyhow because it's also pretty stable. Miet, I think, changes maybe a little bit more than the other two. Zcat tends to be like, oh, I had a great new idea for the next version, and then just makes it, which is wonderful because she creates great libs, but can result in updates. I get most issues with async that they didn't do it single threaded. That means you can start a function in one thread and continue in another. Yeah, I think async and await can get pretty confusing pretty quickly. Absolutely. Threading is a thing, right? Like standard thread or whatever. Like scoped threads are like easy mode. Do we talk about other thread stuff? I think this is intermediate, honestly. I think thread stuff is intermediate Rust. I don't think thread stuff is beginner Rust. Like scoped threads is like very straightforward. But I don't know. In my head, there are domains that are a little bit more advanced, right? Like if you're building the implementation of a database and dealing with the thread stuff yourself, or writing your own async runtime or something like that. Those are advanced use cases, and they pop up commonly when building that kind of critical infrastructure. But I think you have to get to intermediate or advanced Rust to be able to make good decisions for those pieces of software. Whereas comparatively, if you're going to use Axum and write an API, that's a fairly beginner thing to do, right? Accept some JSON, get some JSON, process it, throw it at a SQL database, give it back. That's a beginner thing to do. Not throwing all of the database data into DevNull is more intermediate or advanced. But who knows? MongoDB is still around, so. Rayon is for beginners only. I mean, like pariter, right? Like I could easily make an argument that's like, need parallelism. What do they call it? Data parallelism. Yeah, data parallelism. I don't know that that's a full video, but like, if you are a Rust person and you're like, oh, dang, I wish this thing was parallel, and you have Rayon access, like, drop pariter on it and get some benefits. And like, that's not going to work for everything, right? Like if you stick Rayon into a Bevy app and like, it can compete with other task pools and stuff like that. So like, it's not a panacea. But if you're just going to write your own little CLI tool or something, and you need to do like a bunch of processing on a bunch of CSV files or something, Rayon pariter, absolutely. I don't think having like a Rayon video makes sense. So like, maybe this is a parallelism video. Maybe there's like some parallelism concurrency stuff that we can do for beginners. I feel like once I say parallelism and concurrency, it becomes an intermediate video, but we'll see. Maybe we can mention Rayon in the iterator section instead, since this is going to be a whole video on its own. Maybe we mention pariter Rayon here, and it's just like a little castaway, like, oh, cool. By the way, if you have iterators, there's these great crates out there, and you can call pariter and get some parallelism. And then maybe this then is not a beginner topic. This is a intermediate topic, which makes a lot more sense because threads are an intermediate topic and async is an intermediate topic. So like, why wouldn't parallelism and concurrency be? So if we talk about ownership, we do have to have mentioned variables at some point, whether that's in the ownership section or in the owner or before it, I guess, in its own. Like we could have like Rust cheat sheet. Like here's some basic syntax for a bunch of different things that we'll be using. Here's the PDF that you can download and reference while we talk about things in case you need to. Because I don't think spending a ton of time on like FN is how you write a function and get whatever, like here's how you write a variable and whatnot. The very first thing you did with Rust was slap Rayon on a dumb function that got instant parallelism, blew you away, and you were hooked on Rust. Yeah, Rayon is such a good demo. Yeah, there are other cheat sheets in the world, right? What's that cheat sheet site? Like if I just search Rust cheat sheet, like here's cheat.rs, Here's some other reference. Here's somebody else's interactive cheat sheet. Like cheat sheets are a popular concept, right? Hard for me to call this a cheat sheet when it starts with a table of contents, but I do get it, you know. I think that there's something to be said for like, this is a comprehensive cheat sheet, right? For example, this functions and behavior, here's all of the ways you can write a function, or all of the ways that you can, you know, use something, or all of the ways that you can pattern match and whatnot. There's comprehensive cheat sheet, and then there is, here's the cheat sheet for the stuff that I expect you to use over the next, you know, 8 videos, right? Here are the basics. Here's a regular function with a return type. Here's a variable and a mutable variable. You know, here are the basics. Here's the requirements. I think it's barely assigning multiple variables. It's funny that they say that, and not destructuring or something like that. Multi-dimensional array. That's really funny. See, like operators, I feel like if you've written another programming language, the only operators that you really need to have a cheat sheet for are the like maybe the bitwise stuff, and then like whether it's rem or mod for %, right? Everybody knows what multiplication and division and stuff are. If it's weird, put it on the cheat sheet. If it's not weird, don't put it on the cheat sheet. Yeah, I want something smaller than even this. Something that is literally a sheet. Something that right. There's a whole ton of things here that you're never going to need to care about as long as you're still doing the beginner course. Doc comments in Markdown and how to write Markdown doesn't need to be in the cheat sheet. Like absolute basics, like here's a function, here's a variable, maybe 1 or 2 control flow things, maybe destructuring. Basically something that supports the rest of the videos here, right? Like core necessity cheat sheet instead of like comprehensive. You need a Rust cheat sheet. You can add constant static to variables. Do I want to talk about constant static and variables? I think that people who are learning Rust and have known another language have a bad habit of trying to make global data. Right? Because like in other languages, you can just shove something somewhere and then access it from the rest of the application. And yes, technically you can do that in some capacity with like const and static, right? Const technically gets copied into all its locations. Static doesn't. I probably wouldn't encourage beginners to use const and static. So const and static are probably intermediate topics, right? Like if a beginner was like, oh, I chose to use a const here. I'm like, great. Is it an I32? Then you're good. Is it like a hash map? Maybe not. Right? So like intermediate stuff, const static. Clippy has been telling you not to do modulo anymore. Yeah, because we have, what is it? Is multiple of? Is multiple of. Rust 187. No need to do modulo anymore. Very exciting. And I think the Clippy lint for this went with 190. Is even and is odd. Not here. So is multiple of 2. I do actually really like is multiple of, in terms of, like, especially since percent sign it's not clear whether percent sign is rem or mod typically. I know that was a stab at JavaScript. I know that was a joke too. But I do think is multiple of is a good function to have, because it says more about what's actually happening or what's supposed to be happening, rather than leaving it up to like a symbol that is not necessarily what you think it is if you already know rem or mod from another language. Oh yeah, I'm sure somebody put that on crates.io. That's like like that's a joke that somebody would obviously jump on. Even odd. Check my first crate. I mean, I'm not going to install it. I do kind of wish there was a temporary crates.io. I wish there was a temporary crates.io that I could tell people, hey, if you would like to test how to publish a package, this thing gets cleared every day. Run cargo publish, -- temp, and it'll publish, and 24 hours from now it'll be gone, but you'll be able to see it published. You will get all the warnings that you would normally get when you publish, like, hey, this doesn't have an author, hey, this doesn't have a version, hey, this doesn't have a whatever, like fill out your description and whatever, do the publish, see your docs on actually like the temporary crates.io. Because then you could have people do a cargo publish as part of a course without like occupying crates.io's namespace, right? It would be nice to have a practice area. Or something like published but private only, so only you can see it. Yeah. Well, there's that idea of like organization namespaces would be good for that, right? Because if you have organization namespaces or something like that, then you can have, like, I could have Chris Biscardi, and I could be like, okay, I'm going to publish here, and it's going to be like Chris Biscardi first crate, or Chris Biscardi whatever crate. Can't you create a private repository? Oh yeah, you mean like host a crates.io yourself? I'm not going to do that. I might build the practice area such that people can actually cargo publish. But even that is going to be a little bit weird, because it's going to be like, I'm going to have to like match the behavior to what people would see on crates.io. So it's not really a fix, right? I mean, like, I could do it, but I'm not sure how useful it'll be, right? I think I would prefer if crates.io had like a temporary registry of some kind for educational purposes. Yeah, set up a Docker container. I mean, like, I could run a Docker container, yeah. Run a Docker container, kick the Docker container every day, and whenever it restarts, it's just done. The only other thing, I guess, would be like, I would have to set up authentication and stuff for it. So I would have to like take the Rust Adventure users make those the accounts for the fake registry or the practice registry, and then have everybody like log into that registry with their accounts and then publish to that registry, just so that it can all get deleted. And there's so much that can go wrong there. You meant more that each person that wants to do that section would spin up their own. Not everybody is going to have Docker. Like teaching people how to use Docker is its own course in itself. Yeah. Something around Cargo Fender was published, maybe. Maybe. I don't know. I wish it existed. It doesn't exist. That's the current state of things. I also, like, one of the things that I would like to do for Rust Adventure is have on website tests, or like a service that will run tests. But to do that, I have to have a bunch of like, make sure this compute doesn't run over itself, et cetera, and do a bunch of security stuff. And realistically, if you are writing Rust and you're going to do Rust things, you are going to have it installed on your computer at some point. So I don't know how useful like having examples on the website would be. Cool. So let's move away from that for a little bit. That's enough content stuff for the moment. And then this is hooks and observers stuff. Where's our cargo run visibility? But without the trace features. I'm going to work on the 2D mesh example a little bit. I spend a lot of time doing educational stuff and scripting and pedagogical content thinking, but I don't know. I'm surprised people even liked it last stream, if I'm being totally honest. I'm surprised people even liked hanging out for me developing new workshops. If people are into that, I can do that more often. Like y'all seem pretty into it too today. Totally off topic. What do you think can be done about supply chain attacks, avoiding the NPM craziness? Man. At some point, you have to trust somebody. So if you're going to talk about avoiding supply chain attacks, you have to talk about what your threat model is. If your threat model is maintainer package takeover, then pin to a version or vendor all your stuff. Those are kind of your options, right? Registries shouldn't allow the replacement of files. I know NPM used to have all sorts of things around. You can kind of just like ask for somebody's username if they haven't used it in a while, and like stuff like that. Like obviously not having that is a benefit. But at some point you just have to trust that the person publishing code at some point is publishing like the code. Unless you're going to like sit there and read all of the code every time, which is like by definition impossible, right? Like the amount of code in the average project these days is far beyond what one person is capable of reading, much less actually checking all the edge cases of. That's my viewpoint on it anyway. Like at some point it becomes, I have to trust either crates.io to deliver me the right thing, or the people who are publishing the packages, or, you know, et cetera, et cetera. Because like it's easy to derive a situation in which a malicious maintainer, for example, however it happened, whatever's happening, they publish a patch update and it goes out to everyone, right? Like at some point you just have to trust the maintainer is not going to do that, or you vendor everything all the time and then you're like locking yourself out of software updates. So it's like double-edged sword. I don't know. When people say like supply chain attacks, I would say like it's 50% fear mongering, because what are you really going to do about stuff? Like at some point it's a community and you have to trust people. But I also like, I wouldn't fight against anybody being like, these are reproducible builds on crates.io and SHA hashes and things like that. But like the difference between say curl installing something and reading a shell script before you execute it is there's no different, right? Like, I feel like people are like, oh, you shouldn't curl pipe to shell a script, right? But even if you access that shell script, read it, and then execute it, it can still do something else. Like the NPM supply chain attack this year. There's been a couple of them, right? I don't know about which one you're referring to specifically. But like supply chain attack is very general as a term. And it gets played up a lot. Any issue with any package can be drummed up as a supply chain issue. Yeah, I mean, if you're talking about like compromised accounts of people who actually have access to do things, what are you going to do about that? Right? Like you can have two-factor auth and you can have all these other things, but it like fundamentally, if you can run an npm publish on your computer, this can happen. Yeah, I mean, like security in this sense is like, how high do you need to make the barrier to make it not worth doing? Not eliminating it entirely. So that's my feeling on it anyway. The Arc Linux package manager is being attacked a lot lately too. Is that AUR? AUR? I don't remember what the Arch Linux. Yeah. I've heard about this a couple of times lately. I don't know. As like an individual, I don't feel like there's a lot I can do about other people's credentials getting compromised. Okay, so we have this example. This example is so far doing pretty well, but not doing great. I think there's two major fixes that need to happen here. One of them is that we don't raycast past a point of collision. So it's going to be hard to show that because we also don't do the other thing. We don't raycast past a point of collision. So it only makes the mesh to the shapes. It should be making this mesh with a bunch of shadows behind them. The other thing is that we don't recognize when something is in front of another thing, right? Like if we look right here and I zoom this in, we correctly, when we're at the end of a mesh, jump to the next one, right? The next one we hit, we jump to, and we draw the line between them. That is a correct behavior. What we don't do well is once we cross the threshold, right? Once there are things kind of in between here, we don't track walls. So it might be better to go for the other shapes for the moment. I broke this out into a library. Here's the simpler shapes instead of all of the shapes. I think we can still exhibit the issue here. So here's something significantly simpler, right? Basically, we get bottom left, bottom right, top right, crossover, top left, bottom right. But if we do this, we kind of lose a bunch. Like, this is weird. And some of the logic here, the reason this cuts off is we start at bottom left, we hit top left, we don't track this wall in front, and then also the logic says that what is the actual issue there? We hit that point, we've looped around, we try to check for like this vertex next. So we're kind of going backwards because we're kind of trying to cheat our way into like using the counterclockwise rotation of the face for the vertex positions. And thus we don't hit this one, we hit this one, and then we empty out. So you can see once we get below that corner point, everything starts working again. But I don't know what the correct behavior of being inside this would be, actually. Like, theoretically, you would never be inside of this. And I think that's just the answer, but what just happened there? So, question being, do we cross any lines to get where we're going? I actually think the first thing we should do is have a container. So let's put in another rectangle here. And this rectangle, I want to make this like a full screen quad, actually. But instead, what I'm going to do is just make it like 1,000 by 1,000, which should be enough. I guess we're what, 50, 100, and we're positioning it somewhere. What is going on there? Hang on. I need this to not be here. I need this to spawn individually. This is going to be like our container rect. And we have mesh 2D with some color. I think our color here will be something special. Got to make everything a tuple. And this color is going to be what? I kind of want it to be transparent. Hey, Matt, how's it going? Hide, whatever you want me to call you. And we'll do color from here because these are sRGBAs. So we can't do into because it's like two froms. It's sRGBA into color material. So we need to have an explicit from call here. And then we'll just transform this at the default. So 0, 0. And I think this is going to be gigantic. I think it's going to cover the whole screen. So either that or I am going to have forgotten to do something. Mesh, material, 3D, obstacle. I started making this actually a library. So you do have to start labeling everything with obstacle if you're going to use it. What is going on there? Transform, extent, obstacle. Where's our camera? Is our camera not focused on mid? 2D is on mid. Transform, mesh 3D, that's why. Because mesh 3Ds aren't visible on a 2D camera. So it's kind of cool. We do get some issues here, but as long as we're not... this is an issue. This is an issue. But we do get some good behavior here too. In the good behavior, we still have some issues. These... the vertex from player to top left needs to continue until it hits the wall, which will effectively make this the shadow of the box. So that's really what I wanted to do here, but I think that I'm actually going to leave that box there too. I kind of like that box being there. So maybe... maybe I just add another box. And then this one becomes something really big. Because again, we only search for mesh 2Ds, so I think this has to be bigger. That feels interesting. That feels like an example of another bug where I think this is the same bug that we were talking about earlier, where if there's something in between, then it doesn't find it. So like the intersection of these two walls effectively has to be a point at which we draw a vertex, and we are not doing that. I don't know how we're going to do intersection like that, or if I'm just going to say that it doesn't support it. Doing good. How are you? Doing all right, Hyde. We did some, let's see, we did Tracy stuff at the beginning of the stream. Then we did observer example stuff with entity component triggers for Bevy. Then we did some Rust workshop development stuff for videos that I'm going to try to record this weekend for Rust Adventure. And then right now we're doing, or I'm intending to fix some bugs with a 2D visibility application. Yeah, let's just double this. I just want it to be like really big. I want it to be bigger than the area of the playing field. Realistically, I think this should be, how do I frame this? Realistically, I think this should be the size of the screen or the size of the level, like that kind of thing. It's, there are some issues here for sure. I still want to be able to see the mesh. I don't want the edges to leave the screen. So maybe is 800 by 1200 going to be enough? That's the wrong dimensions. 1200 by 800. That's what I meant. And then maybe I zoom the camera out a little bit. The final result, do you want it to be a spherical or a cone in the direction of the player view? The direction of the player. This is going to be the mesh on which you could intersect with something else to produce a final result. So this is going to be the full everything visible mesh. So it's going to be square and triangles, right? If we look at this full thing, right? This should go from bottom left here to bottom left of this square. And the triangle here should go all the way to the wall, down to the corner and back to the player, right? And then this should go to bottom right on the red, top right. And then once it hits top right here, this should also extend to, so the two lines here that aren't extending from top right and from bottom left need to extend to the wall, which gives us the shadow behind this block. And it'll be inside of this square. Everything will extend to the edges of the square. And then if you wanted it to be either a circle with a fall off, or you wanted it to be more like a flashlight, you could intersect whatever we're going to render to texture here with another shape, like an SDF or something, or, you know, any kind of whatever you wanted to display, you know, whatever the player could actually see with a flashlight. So the spherical effect would be after we make this mesh and after the mesh is correct, if we intersect that with a circle. Create a stencil then. Depends what we're doing with it. It depends what we're doing with it. We're definitely going to render to a texture, right? I think for this example, I'm trying to make it easier for people to approach. So I think actually what I might do is have another camera 2D, have it render just the player mesh, the visibility mesh to a texture, and then use that texture in a post process. And that'll be the example. Because the alternative is building a custom render phase to render things in different ways. And I think that's a little bit overkill. So I think we're just going to render layers, the actual mesh. So we're never going to see this mesh, this yellow thing. This yellow thing is not going to show up like this. It's going to render to a texture. That texture is going to be used in a post process to make something happen. The other thing we can do is probably guard visibility would be cool. So we'll have multiple of these running, and the guards will have their own visibility meshes, and those will get, I don't know, something like avian sensors, maybe. And if you walk into their line of sight, you get seen. There's like multiple applications for this. One of them is lighting. One of them is like NPC visibility or enemy visibility, etc. So the question is, do we want to write the raycast? Or do I want to write the interference? Do I want to debug this? I think I want to debug this. This feels worse. So then, in our library, I got rid of a bunch of our debug info. I think I should write a system that just shows the order in which they are being applied. Let me zoom the camera out first. Projection, orthographic projection, default 2D. Love that we have default 2D now for orthographic projection, specifically because the near and far planes are different between 2D and 3D. So doing an override of the projection used to incur the fact that you would need to set the near and the far planes again. But that is no longer true. So let's do fixed horizontal and let's do 1300. Orthographic, forgot that was an enum. So that should keep our entire thing on screen. If I did that correctly. Yeah, perfect. So now we get to see everything on screen all the time because we know how big that is. This does cause issues with like the mouse is no longer moving at the same rate as the things on the screen. So if we wanted to bring that back to being accurate on this little ball, which I don't really care about right now, we would have to take the multiplier from the scaling mode and use it here to figure out where the mouse is relative to that. But again, I'm not super concerned about it at the moment. I'm more interested in debugging this issue. The other thing is that this is very messy code. This is like stuff that I wrote on stream, one off, and then kind of like quickly cleaned up after stream to get to a working state, but is not like dang, it's so close to being like actually cool and useful. So our access patterns here are interesting, right? The thing that we're doing at the beginning of the function is getting all of the vertex positions for all of the vertices for all of the meshes that are obstacles, right? We've left player in here. I don't think this is going to be a thing that you can apply to multiple, so we're going to have to replace player with like a different stamp, but for now it's just player. We've changed this to be looking for with obstacle, which is just a marker component on all the mesh 2D global transform combinations. That's how we're getting all the vertices. This logic is just getting all the positions, which we then add the global position to, and then we set up visibility data. And visibility data is mesh 2D, the index of the vertex in that mesh 2D, the angle from the player that vertex is, and the global position. So this is data that needs to be recalculated every frame, or it goes out of date. As long as the player is in the same different place, as long as the player is moving, this needs to be calculated. So technically right now it wouldn't need to be calculated, even though it is being calculated every frame. So we end up with this visibility data that is a vec of vecs. And what this ends up being is every mesh has a vec of visibility data for every vertex. And we end up having to flatten it, to sort it, to turn it into a peekable thing and iterate over it. Then we iterate over it. And we haven't done any access yet, right? We're iterating over all of the sorted positions. So let me over all vertex positions sorted by angle to player, right? So what we should see actually, if that is true, is we should go from this bottom left to actually this point on the bottom left of the red square. I don't think we do that. But it's also not clear because it's overlapping. So we need to figure out what order these are being visited in. So our access patterns here, we get into our loop. And we're kind of storing two pieces of data. We're storing three pieces of data, but two of them that matter to us on each loop. Skip to and current vertex. So we've got the current vertex that we're dealing with, which on first iteration is nothing. So we end up here, right? Current vertex just takes the global position and sets it to the current vertex. And we're going to skip to the next index. So I think actually that would give us the bottom right of this outer box. I think the interesting thing here is that because we are now inside of a box, the assumption that we were running doesn't hold anymore. Which is we were kind of abusing the fact that these vertexes are ordered on each of the meshes. And really that depends on whether we're outside or inside of the mesh. Right? So we should be going from bottom left to top right. And at some point here, we need to do the calculation that stops us actually at the other mesh. So if the angle is shorter than the current vertex, right? I think it's actually greater than in the order that we're going. But if the angle is shorter than the vertex that we're going to for a closer vertex, then we have to use that closer vertex. So I think the first step we need to do here is definitely the debug the vertex visit order. But let's take a brief step through the access patterns still. So if we loop through again, we have, what do we have set? We have current vertex and skip to set. So we're never hitting this. or rather, we hit that quite a bit. Let's log continues. Of course, the only thing that's logging is continues, so we don't know where it starts. Whoops. Let me log something at the beginning. This new line is what we were using originally. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 skips. And we have 4, 8, 12, 16 total vertices. And we're using about 5 of them. 3, 4, 5. Yeah, 11 skips, 5 used vertices. So all of the vertices are getting touched, at least, which is good. We had ray index for detecting which one we were doing. So ray index is no longer getting set, but it should be. Where do we have the logic for this? I think it's in main. Maybe I deleted it. Did I really delete it? On drag, setup. Set ray index. No, I didn't delete it. So this kind of shouldn't be here, I don't think. Or rather, it shouldn't be where I'm about to put it. But it is where we're using it. So I'm just going to plop it in here, and I'm going to steal the ray index. Well, maybe we just expose it, make it clear that we put it in there, but it's not supposed to be in there. Let's qualify that. Of course, green isn't found in the scope. So we import it. And this has to be pub too. Probably actually what that was warning us about. And we'll qualify this instead of importing it. So according to this, our first vertex is actually the box. Interesting. So that's why we get skipped. Because the first vertex is actually the bottom left of this box. We end up with the top left vertex, right? So we've built all of this interior area here. And then because we're inside of this box, it skips to this vertex instead, which means that all of these get skipped because we technically haven't been to this one yet. So realistically, what this should do is if we're inside of the rectangle, do the other direction. How do we detect if we are inside of that rectangle? Everything that I can think of immediately off the top of my head means we have to check if we are inside of every rectangle. We could do something like reverse the clockwise rotation of the vertices for anything that we're inside of or can be inside of. That's not really a solution, that's a hack. So the question is, given the current vertex, if we use Bevy's built-in intersections, we can only do squares and circles, which is disappointing. So I would like to avoid that, even though that would work. We could make this not a rectangle. We could make it 4 lines and kick the problem down the road. I'm actually really curious if we do something really silly. I think the vertex winding doesn't change, but where is our shape? I'm actually just curious to know what happens if we set kind of ridiculous. Same thing. So the vertex winding doesn't change, so that's what we're depending on there. You think the way to see if something is inside a mesh polygon is to shoot a ray in the direction and count the number of times the ray. Oh, right. Oh, right. And if it's odd, you're inside, and if it's even, you're out. You're so right. How can I have forgotten that? So the question then, but why should we do this? So we're taking a shortcut is why. So the options then are, right now we rely on kind of a hack that I thought was kind of cool if it would pan out long term, in that when we, if we hit a vertex, right, we kind of have to calculate which walls come off that vertex, right? So our options are find the vertices on either side for the 2 walls that come off, right? And pick the one that goes in the right direction, or just assume that index +1 is where we need to be. So I did an optimization where we are currently assuming that index +1 is where we need to be, but that doesn't pan out if you're inside of something. It pans out for everything that you're outside of. Actually works for literally everything here, right? It doesn't work if you're inside the shape. So I could just label it right. I could label the big box as like the container box, and then do the iteration in the opposite direction for any box that is labeled that. I'd have to keep that information around somewhere, like in the vertex visibility data. However, We do need to do raycasting pretty soon. We specifically need to do raycasting for this green line here. Only goes to this vertex. We need it to actually go to this edge. Which I guess theoretically could be the window. Right? The window edge. Instead of this box. But I thought the boxes would be cool because if you did the boxes, that would mean that you could move from room to room and block rooms based on the rectangle or the geometry that you chose to build the visible area container out of. And I kind of like that. I like that some rooms would be like visible and then some rooms like wouldn't be visible until you broke a door or something. So the options here are to either get both vertices or get, can we do something more generic that works for any edge? If we're on this vertex, then we need to find the next vertex that is the shortest distance and the least angle, right? Shortest distance, least angle, shortest distance, least angle, shortest distance, least angle, shortest distance, least angle. I don't know if that pans out for everything, but it seems to pan out. Shortest distance, and then this would be shortest distance. Least angle would be we have to cover basically going from vertex to vertex on the same shape, going from across a gap, right? From this vertex to that vertex, or from that vertex to this vertex specifically. And we have to cover a shape being in front of another shape. Am I ignoring half the vertices? You can only see 180 degree of the coin. No. The issue, can I make this happen? The issue is that we're inside of this shape. There we go. The issue is that we're inside of the shape, so it becomes a little bit weird. We're actually not ignoring the vertices. The algorithm that we currently have implemented is, I think we start west, and this goes for the first vertex that it finds. So we just jump right to this vertex. This is our starting ray, right? Here's all of the vertices laid out. From here, we make an assumption based on the way that meshes are organized in Bevy. And that is the vertex order to show a face is counterclockwise, right? So all of these triangles are built counterclockwise. So if we go from here to here, then that is index +1 on the mesh, which is very cheap for us. Like it's very easy for us to go, oh, we were at this vertex. We'll just use the next vertex. And then we'll use the next vertex. So once we get here, we do a calculation where We try to find the next vertex, but it brings us to the top left of this box. And when it brings us to the top left of this box, we know that the angle of the vector from the top right to the top left, from the player to top right compared to the player to top left, just to be clear, is less, which means that we would have to go backwards. So we're only, I don't know if this is going to show up if I do. We're moving clockwise with our ray rotation, and we're moving counterclockwise when we choose the next vertex. So if I can, yeah. So the first one is bottom left. And then the next one that we reach angle-wise is actually top left. But that gets skipped. This gets skipped because we're looking for this one specifically, right? We went +1 on the mesh because we have a wall that goes between the two. And we know that nothing past that wall can actually be, like we can't connect with anything past that wall. So we just go straight to this vertex. We do the same thing for this vertex. And then we cross the gap. We do the same thing for these. So we skip this and go straight to this vertex. We go to that vertex. We cross the gap again. We cross the gap again. And then we go bottom left. So we skip that one, go bottom left, bottom right, cross the gap. And then we go to this one last. So the calculation for being inside of the box, the reason this is a problem, right? Which I think is the same reason this is a problem, is it? Let me think. Anyway, the reason this is a problem is we still start at bottom left, go bottom right, skip top right. We make it to the top left. And then because we're inside, when we try to go counterclockwise on the vertex rotation, we go backwards to the beginning. And that causes us to skip all of these. So it's kind of due to a silly optimization that I thought was going to be useful and actually isn't useful once you're inside of other geometry. So my thought is, how do I want to deal with being inside of this rectangle? And the answer could be, when we hit this vertex, we just get both sides, both options, before and after. And then the question is, which one do we use? So I was thinking through that. I got lost in the explanation, but because I think if we logged this out, go to lib, go to, let's bring our nexting the gap back. Let's bring our, what other logs do we have in here that were useful? Skip index, next vertex. If current angle is greater than next angle, then next vertex is behind. Yeah, so it's not less than because it's greater than, but why did I flip that in the description? That's really awkward. So the thing is, if we're inside, then right now we're just doing skip index +1 to find the next possible vertex on the current mesh. And I think that sends us in the wrong direction. Like continue, nexting the gap. A bunch of continues. We need to log out when we're actually hitting something of note. So these are our logs. This is the bottom right vertex, if I remember correctly. We aren't logging our first position, which would probably also be useful. It's really funny because I feel like building up a bunch of examples both would help me build the algorithm and also be good for videos. But doing everything in depth and building all the demos is very time consuming. So we start at -525.25, right? And we go immediately to -475.25. I guess we don't have an image to look at, so let me do this. So our very first vertex is this vertex here, bottom left, -525.25. Then we skip to -475.25. So the bottom right is the very next vertex we see, which is good. And then we continue, which means we skip a vertex, which is this top left one. And then we hit -475.125, which is top right. We next the gap to get to top left. Which I think means we get to -600, 400, which is top left Y. And then we continue until we get to the bottom left. So something happens when we skip on that top left, and I think it's the mesh order. Or the winding, right? Next thing the gap, yada, yada. So the question here is, we currently just do +1. But really we want the closest, we want the smallest angle to the closest vertex. And I think that's true for everything. Smallest angle to the closest vertex. Let's see if that's a better algorithm to use. So if we're here, smallest angle goes to here. But then determining closest vertex would require iterating. So to go from here to here, for example, this would be smallest angle, but the next one is closer. So maybe if it's, we can't actually tell what kind of shape it is when we're doing this. So we don't know that that is actually going to be there, right? Because this could be just a triangle to this position, like a right triangle, bottom left. So really the algorithm would be, if it's on the same mesh, then it has to have a wall connecting to the current vertex, which technically speaking for complex shapes, I don't think is true. Because if you have like a U shape, right, then that wouldn't work. So the question is, am I getting myself stuck in thinking about all of the edge cases before writing any of the code? Or am I... Or is this a good time to actually stop and figure out what the algorithm should actually be? The only way to tell if we're inside of something is to do some kind of collision check or like bounds check, right? Which I don't really want to do. Let's check the 2D blog post. Maybe I missed something. I feel like it didn't have a ton of explanation about what actually to use. Right. Here's the demo for what this is actually supposed to be. This happens to use the mesh to then build lighting. So like you can see a bunch of like individual triangles there and whatnot, which is cool. And you can do this in a bunch of different ways. They start out with like a simple approach is to cast rays from the center. This was like obviously the wrong choice in my mind, because this depends on the resolution of how many rays you can cast, which is always going to miss, right? It's always going to miss vertices. It's always going to have issues, which is true as far as I can tell. They don't do a full treatment here, but like it depends on how many rays you can cast. So then they'd say, let's cast the rays only at angles where the walls begin or end. So at all the vertices. Triangles produced by those rays are the visible areas. But they're doing full ray casts past it to the edge, which is a little bit awkward. You see two things. First, this inverted order. Second, sometimes when the next vert is not visible, then the next point is not a vertex position, but the projection of the last vertex onto an edge. Yes. We aren't doing the projection. I'm not terribly worried about the projection. The projection feels I'm not going to say straightforward, because we're going to have to find the wall and find the position, but we're going to be able to project that ray onto whatever wall is there, right? We're going to be able to do that. I don't love that this requires a bounding box, but maybe it's just like that. combine the ray casting and wall intersection into a single algorithm. So this is the sweep that we're doing. So if I show this and they go like this, it's, let's put it this way. It's unclear how that becomes the first triangle to me. Right? How would you know that this triangle on the bottom left exists if your ray starts west? That's one of the things that is really confusing to me about this particular demo. It's like, okay, we hit a vertex. Let's do a backward look for the last vertex. Anyway, sweep a line around a circle, hitting all the points sorted by angle. We have a sort by angle. For the area between consecutive rays, we want to find the nearest wall. They don't describe what the nearest wall is. And they don't describe how they find the walls. Right? So like, you hit this vertex. It's unclear what they're thinking of as the nearest wall. But for their algorithm, they hit like all 7 of those vertices, and we just skip to this one. And then we skip to that one, and then we jump, and then we skip. The thing that really confuses me, again, about this demo is that when you hit this first vertex, why does this triangle get built? Right? That triangle doesn't make sense to me. Because like that means that like you already know about a vertex that you didn't sweep yet. So like somehow this knows what the last vertex is and is drawing the line there, but also casting to the outer. I don't know. Next step is to keep track of which walls the sweep passes through. Only the nearest wall is visible. I don't really see how that's different. Can we reset this? So they've got these two, right? This sweeps like that. This sweeps like this. These produce the same output as far as I can tell, but they're talking about them as if they're different. So maybe they are drawing all the lines to all the vertices. Yeah, and then there's this. The demo uses a slightly more complicated approach, which I won't explain here. So we're on our own for sure. And I think I just need to sit at this and stare at it, especially probably off stream. Not the blog post, but just the algorithm that I'm using. I know all of the issues, right? The issues are all apparent in the sense that we have the debugging tools to figure it out. We know what order our rays are going in. We know that when we hit the top left, it's skipping all of this. We know that that's because the winding order is going counterclockwise, which takes it to the edge. And we need to prevent that from happening. There are a number of ways we can prevent that particular thing from happening if we know that we're inside of something or if we label it as reverse. then we can deal with it like that. The other option is not using a rectangle, but instead, do we have lines? Yeah, we do have lines. Can we do lines? I've never drawn lines with this particular method. Right, line 2D, direction, infinite line, segment 2D. We want a finite line. So segment 2D, point, point, we can do that. So one of the other things in general, especially like game development wise, is like sometimes people are just like, oh, by the way, this won't work if you X. So our thing right now won't work if you're inside of another triangle, which is fine. We can always choose to try to fix that later. Right, so vec2, 1200, 800, vec2, new, 1200. So we want, let's start with negative 1200, 800, and then 1200, 800. I guess this is the width, right? I actually don't know if that rectangle was half size or size. I guess we'll find out when we run this. I think it was half size. I think it's negative 600 and 600 is what we want. And then 400 and 400. So this is what? Top, left, right. So we're at right, top, bottom. Negative, negative. Negative, positive. So this should give us 4 walls, right? Why do I feel like that is not the same size that we had before? Do we want 600 here? Is our width okay? I think our width is okay. There we go. Interestingly, that has the same issue. Plus other issues. So I wonder if the order of these matters. But either way, we have to fix it kind of a different way, right? So here's our non-reversed or whatever version. This seems like it... Where's the triangles here? It's definitely drawing to each of the lines, which is interesting. Which is, I think, expected, actually. So on the left-hand side, what happens is we start with the box vertex, which is why we get it. On the other two, what we're actually doing is starting with the line vertex, and then we end up skipping because these things are not picked up because we haven't coded the like rectangle in front yet. So I think what we end up doing there is like the projection on the line anyway. So like the... You would try a naive way that might work for all the cases. And for the first vertex or when the next is not in the ordered list, same mesh, go back into the list and project. Yeah. The thing that I'm thinking about now, because I just basically eliminated the reverse vertex order issue by not being inside of a rectangle, then we have the actual issues, which are we don't have projection and we don't deal with objects that are in front of a wall that we're skipping. So in this case, if the distance to the next vertex is shorter than the distance to the projected line, then we should use it. So we have to do the projection regardless. So if we have to do the projection anyway, do we want to build up a structure that is all the walls? It's an interesting thought. I think that's a thought for another stream, though. It's about 11 o'clock. I've been doing about slightly shorter streams since I'm doing them basically every day. I will be back tomorrow morning, where we'll do some more Bevy stuff. Saturday morning is Bevy stuff. So thanks everyone for hanging out for all the educational stuff and also for the other stuff. I'll keep working on this demo. I need to get this algorithm correct, but I think that I'm not going to get the algorithm correct while I'm streaming. Do you upload this to a repo to reproduce at home? Yes, this will all go to a repo. If you're interested in playing with it before the next stream, I will push it up right when I'll push it up right now. I'll commit it and push it up if you're interested in running it. Let me... Examples, 2D visibility mesh. What does our cargo lock look like? It's that. What else do we have here? That's just a cargo format. That's not how you spell visibility. And then I'll stash. No, I have to commit cargo toml. And then I'll stash, and then I think I need to pull and rebase is the thing that I have in my head. So then I push. And if you do !Discord, you can ask me any questions you want to about it. And also the link to the repo will be in the Discord as well. Rust Adventure, Bevy examples, 2D visibility. Here's the actual link. So if you want to play with it, you can absolutely play with it. This is not, it's not a finished demo, is the way that I'll put it. So don't expect like well-curated, like pedagogical material here. This is an in-progress demo that I first need to finish the implementation of, and then I will clean up, and then will be actually something worth learning from. But if you want to play with it now, you're totally free to play with it now. I pushed it up. If you figure anything out, feel free to let me know. The Discord is where I didn't, you know what I didn't do? I didn't start the bot. Oh, I did start the bot. See, I'm such a good streamer. If you have any questions or anything, feel free to ask them. I hang out in that Discord, or I'm in the Bevy Discord too, et cetera, et cetera. But thanks for hanging out, everyone, and I will catch you tomorrow morning if I can find the end stream button.